Now let us consider retaining structures. Retaining structures required not only for the structures above ground level, but also for the structure constructed or structure required below the ground surface. During underground construction, generally retaining structures are required to retain the soil during excavation and during the construction activity. Example, during laying of water supply line, sewage line, and even during construction of canal, and during construction of basement floor. Also during the construction of top-down construction, means if you intended to have more than one floor below the ground surface, up to the required level as per the requirement is known as a top-down construction. We will discuss this top-down construction a little later whenever it is necessitated. Likewise, retaining structures are also required above ground. Retaining structures are of two types. It is a temporary and permanent. Temporary retaining structures are required to retain the materials, maybe a soil or liquid, temporarily during construction activity or during the diversion activity. During construction activity, sometimes you require to retain soil, and the same time you need to retain water. Sometimes we need to divert the water from their natural direction to other direction. It is called as a diversion. There we required a temporary retaining wall. Temporary retaining walls, retaining structures may be in the form of bund or in the form of coffer dam, we can call it as. These coffer dams are generally used during construction of the foundation for a bridge pier, bridge abutment, where the stream or river is a perennial one. So to divert running water from one side, that is particularly from the site of construction to other side, to make the base of the foundation as dry as far as possible. So permanent retaining structures are also required to retain the soil in order to have the various structures, namely a building, a playground, an embankment for the road or a canal, etc. Varieties of retaining walls are there nowadays. It is conventional retaining wall and non-conventional or regular or a recent retaining wall. The conventional retaining walls are maybe a gravity retaining wall, a cantilever, a counterfort. 4 type of retaining wall. Recent trend is it is a sheet pile wall, reinforced earth wall, anchors and bulkheads. Here in conventional retaining walls, the gravity retaining wall, generally gravity retaining wall is of the stone wall. The cantilever retaining wall is of RCC wall, and this counterfort type of retaining wall, again this is an RCC wall. The detailed design and construction we are going to learn in the upcoming semester under the different heading. So these are considered as conventional walls, and the design principle here is the walls design should be safe against sliding, and should be safe against the overturning and should be safe against the bearing capacity failure or foundation failure. So these conventional retaining walls are time consuming retaining walls, and the recent type of walls are sheet pile wall, reinforced earth wall, then anchor. These are again it is recent type of walls and they can be constructed quickly. Sheet pile walls, generally sheet pile walls are of steel waterproof walls, and these sheet pile walls can be used as a semi-permanent retaining structure or a temporary structure during the construction activity, maybe in during excavation below ground surface or even excavation above ground surface. Reinforced earth wall is the order of the day. These are generally employed in practice wherever the embankment are necessitated, particularly during the underpass construction or it is overpass construction. There we require cutting. During underpass it is require cutting, or during overpass it requires embankment. Under both circumstances we can use reinforced earth wall. Reinforced earth wall is nothing but inserting the reinforcement to the back of the wall by means of suitable means is known as reinforced earth wall, and it is quite economical, and also it's a quick way of constructing retainment structure, and sometimes we can save the cost also considerably. Similarly, when these two systems are not possible to apply, then we go for the anchor and the bulkheads. There it is suitable anchorage to the back side of the embankment or excavation. We can support the material. So likewise we can have retaining structures. To know to have suitable retaining structures, one should have the idea about the retaining structure in addition to the underground designing and construction of structures. Next, the fourth, the field of civil engineering, which it is we are interested with the soils and it requires the knowledge of soil, is the design of embankments and excavations. As we are aware that there is no structure without foundation, whatever the structure we are involved in construction activity, for all the structures require foundation. Foundations are laid below the ground surface. To lay foundation, first we need to excavate till we reach the reasonably hard strata. Over the hard strata we construct the foundation, above that the required structure will be constructed. When we excavate soil to lay the foundation, the excavated after constructing foundation we need to fill the soil, that is known as backfilling. And backfilling to be again engineered, it should be engineered fill. Unless it is to be properly filled by means of suitable compaction in order to reduce the pores, there may be a fatal the lowering of the ground surface, or it is called as the settlement. That is not the desirable. So idea of the filling, how that filling to be take place, how filling to be made is the foundation fill or excavation fill. Then again in order to have various structures, it has to be filled, the ground surface to be filled, so to have the level surface as per the requirement. The fill as it is, if you fill as it is, it won't serve the purpose. Filling to be carried out in a systematic manner. That is, it has to be filled layer by layer, and again it is to the layer to be compacted, simultaneous layer to be compacted in order to achieve the desired strength and to reduce the pores or voids. So, this engineered fill is known as embankment. Embankments are necessitated for the smooth movement of vehicles in the case of roads, railways, in case of construction of playgrounds, airfields, etc. In the case of roads, in order to have the desired gradient, particularly in undulated area, we need to construct roads in embankment. Road embankments are generally trapezoidal in shape. So, these trapezoidal shape structures to be constructed systematically by spreading soil layer by layer up to the desired level. So, the soil to be selected for embankment to be decided based on soil concept. One should consider the soil which is having both the cohesion and internal friction for embankment, as sand cannot be used for the construction of embankment. And again, we should have the idea of the availability of soil. In majority of the places at the site of the construction of embankment, we don't get the desired soil or required soil. For that, you need to identify soil nearby. The identified area is known as borrow area. From the borrow area, we have to borrow the soil and it is to be tested in the laboratory for their the properties, and then the soil to be used in the field. The used soil at the field has to satisfy the property obtained in the laboratory. All these ideas are required for a civil engineer before taking up the construction of embankment. In addition, as soil is not concrete, we need to provide suitable slopes for construction of embankment. The slopes to be provided on either side of the embankment depends upon the height of the embankment required. So, the knowledge of slope to be provided is also a prerequisite for a civil engineer. During excavation also, excavation it is particularly in case of the canal excavation or during the road in cutting, particularly in hilly area. In order to have the road at hilly area, we need to cut the soil and then it has to be filled wherever it is required. Again, at this cut portion, unless we provide a proper slope, it won't stand for a long time. Then there are every chance of sliding, and one should have the thorough idea about the slope to be provided for excavation before taking up the excavation activity. So, both for the construction of embankment as well as excavations, the idea about the soil, their properties and slopes to be provided for the embankment and excavations are very much essential. The efficiency of the excavation or this filling means embankment purely depends upon the care taken during the construction activity, maybe during the embankment construction or during the excavation of the soil. Next, moving to the fifth field of civil engineering is it requires soil mechanics knowledge is a design of earthen embankments, design of earthen dams. As we know that dams are the obstruction constructing across the stream or river. The very objective of constructing a dam across the stream or a valley or a river is to store water. If you construct a obstruction, means in the form of bund, water will store at the upstream side, and the stored water can be used for varieties of purpose, mainly for domestic purpose or for agriculture purpose or for the generation of hydroelectric power. Depends upon the site condition, we decide the material for the dam. If the site at the site, that is at the site condition means dam for this site for the dam at the particular site is a narrow and a small one. If it is a stream is like this, a deep one, the dam site is very narrow and the length of the dam required is very small, then it is preferable to go for a masonry dam, or it may be a concrete dam or a reinforced cement concrete dam. On the other hand, if the length of the dam required is extended to a considerable distance on both the sides of the mother valley, generally we call the deepest valley where the water is continuously flowing is known as mother valley. If the dam is extended on either side of the mother valley, then the length of the dam required is more. Under such circumstance, in order to achieve economy, generally we go for a concrete portion for the mother valley portion, and the earthen embankment on either side of the mother valley portion. Before taking up the construction activity, engineers should have the idea about the foundation soil and their properties, both the index and engineering properties. The index and engineering properties, the most commonly using index properties are specific gravity, in situ density, consistency, particle size distribution. Engineering properties are permeability, compressibility, then shear strength, of course the compaction characteristics. So one should have all these idea. Knowing the properties of the soil at the base of the foundation, we need to decide the type of depth and extent of the foundation. Then after foundation we need to construct embankment on either side of the mother valley. Again, to decide the embankment, height of the embankment and slope to be provided on either side, we have to select the soil, and the selected soil should satisfy the criteria, such as it should withhold without sliding. For that, the soil should possess both cohesion as well as angle of friction. Then, even before taking up the embankment construction, one should have the idea about the water flowing, or that ability of permitting water through the body of the dam, and that capacity is known as permeability. And after knowing all those, one should decide the construction of the embankment. Before taking of this embankment, we should have thorough idea about the seepage conditions of the dam. Seepage means it is, we take uttermost care while constructing dam to avoid seepage of water through the body of the dam from upstream to the downstream side. For that, we use generally two types of soil for the construction of dam, and one is the impermeable soil, means the soil will not permit more water to flow through it. The other one is permeable soil, which permits movement of water. The central portion of the dam is to be constructed by using impervious soil, and it avoids movement of water, means seepage of water to a maximum extent. The outside of the core is constructed by means of well-graded soil, and this well-graded system will enhance the strength of the embankment, and this strength will resist the water pressure. To resist the water pressure, the outside of the dam, that is outer shell of the dam, it should be a well-graded one, and to avoid seepage of water, the inner portion of the soil should be impervious one. And we take uttermost care to avoid seepage as far as possible. Even then, there is a movement of water, and the moved water should be safely disposed of at the downstream end. The flow pattern of water through the earthen dam is generally like this, and this line is known as the saturation line. So on this line, it is the degree of saturation is 100%. Below this line, there is a positive hydrostatic pressure, and above this line there is a negative hydrostatic pressure, and this line is known as the phreatic line. If at all, if you don't take precautionary measurements at the tail end of the dam, this seepage water will start removing the toe portion of the dam in the upward direction, and it is not the desirable condition. To avoid this covering of the dam in the upward direction, we need to provide a filter media at the downstream side. So this is known as the filter drain. So engineers should have at least a rough idea about all these before taking up the earthen dam construction. Another type of another field of civil engineering is, it is design of waste containment. We are very familiar about the container, and also we are very familiar about the waste bins. It is majority of the municipalities and corporation, they used to provide two dustbins to each houses. One dustbin is for storage of wet waste, and another one is for dry waste. Wet waste, it is the waste vegetables and the waste generated in household. Dry waste, paper, plastic, etc. This, if you leave this wet waste as it is for more than 1 or 2 or 3 days, you can enjoy the beautiful smell. That is what it is. While collecting the waste, they collect in separately dry waste and wet waste, and that wet waste they will dispose at the outskirts of the municipalities or corporation. Continuous dumping of that wet waste leads to accumulation in the form of huge deposit, and if water falls on that deposit of wet waste, and it will decompose, and it will generate both liquid and gaseous form. The liquid generated will try to move in the downward direction in the form of leachate, leading to the contaminating, sometimes it will contaminate soil as well as the underground water. The gaseous matter which formed will again it will pollute the atmosphere and the nearby people. To avoid this, these days it is for all the municipal corporations to have the waste containment system. Containment is again it is just like a container having the bottom and top like this. So, container fill the wet waste and close the waste by means of a cap. It is a container. It is a small storage. For a big storage where one can expect ton stuff together waste per day. Under that circumstance, we need to identify a suitable area, preferably at the outskirts of the city. There, before start dumping the wet waste, we need to provide a suitable liner in the form of a concrete or soil. Again, if you provide a concrete liner, it is sometimes it gets damaged because of the reaction take place, because when it comes in contact with toxic leachate. Generally, this liner is in the form of a clay, or clay. It is embedded with the plastic material is called as geosynthetics. Then when once this the waste comes to the brim means top, it has to be closed suitably again in the form of a clay layer. Again this clay layer is embedded or reinforced with the suitable reinforcement. Finally, it is after decomposition of waste, there will be generation of gas, and that generated gas can be used for as a source of energy for various purposes. And after the elapse of time, this the waste sometimes it yield as a very good manure if it is a non-toxic waste. If it is a toxic waste, then it can be left as it is, and we can select another site for the landfilling. And this is the order of the day. In order to take care of the environment, both above and below the surface. Below the surface means we have to take care of the soil pollution as well as water pollution. Above the surface, we have to take care of the air pollution. And again, to provide aesthetic appearance particularly at the outskirts of the city. You might be seen in even some district headquarters or cities at the entrance of the city itself, we can see the heaps, big heaps of the waste to both the sides of the road, and even at the exit of the city also. It is a common tendency to dump this waste at the outskirts of the city, even whether it is at the entrance or exit. That should be avoided. That is possible only by the proper design and construction of these type of waste containment, and this is the order of the day for a civil engineer. So these are all the various fields of civil engineer that civil engineer should have the idea about the soil mechanics and their behavior. Having discussed about the soil mechanics, history of soil, then various types of the formation of soils, then the deposition of soil based on the various transported agencies, the various soils coming across in India, and the field in which the soil mechanics is involved. Let us proceed to the actual soil mechanics, and before getting into the actual soil mechanics, let us group the soil particles based on